Welcome everybody. Today in this video I'm going to be talking about OSPF MD5 authentication keys. I'm going to be doing it on two different platforms. I'm going to be doing it on Cisco and I'm going to be doing it on Juniper because I have to learn Juniper now. So I'm your host CCNP Seth. Let's get into it. So first with Juniper, I'm going to show you how to set up authentication keys using MD5 hashing, and I have some example configurations here. But one thing that I want to point out about Juniper is that when there are multiple keys on an interface, it will always try to use the highest valid key. So in this example, I have a start time on when we are going to transition over to new keys. If the start time is going to be December 30th at 4:32, and then the second key is going to start at December 30th at 4:49, as long as it's past those numbers, they're both valid. But which one is Juniper going to use on the interface? It's going to use the highest valid key, which is the number which is denoted right here. Okay, so this is just a simple configuration on how to do it on Juniper, and I'll take you through how it works and some of the show commands on the command line. Now with Cisco, there's two different ways that we can do it, and we're actually going to have a Cisco router and a Juniper router, and they're going to peer, and they're going to have a neighborship. So with Cisco, there's two ways that we could enable MD5 authentication for OSPF. We can use a keychain, or we could use the interface key command. When you implement the keychain on OSPF, you go into the interface and you say IP OSPF Authentication Keychain, and then give it the name OSPF. When you do the interface command, you actually have to do two commands. You say IP OSPF Authentication Message Digest to actually turn on authentication and use MD5. Then you actually put in the key, and you could put in multiple keys. You say IP OSPF Message Digest key 1 MD5, and then the actual key string, okay, or the password. One thing to note while using a keychain for OSPF. OSPF will always use the highest key ID to sign egress packets, meaning packets that are sent out of its interfaces. This is in contrast to EIGRP and RIP, which uses the lowest key ID. So OSPF uses the highest, EIGRP and RIP will use the lowest valid key ID. When packets come in, to authenticate those ingress packets, OSPF will try to use the key indicated inside of that received packet. So for example, if OSPF is using key 3 to send out egress packets, and then a key comes in a hello packet that has key 2, then OSPF will look up it in its keychain to see if it has a key 2 and if the MD5 digest matches. Okay. The interface keys are sort of similar. While you use the interface keys on OSPF, OSPF will use the newest key that is added to the interface configuration. This is regardless of the number. So if I put in key 2 first on the interface and then I add key 1 later, OSPF is going to try to use that key 1 first. Okay. So like it says here, regardless of the key number. Now, when it authenticates ingress packets, OSPF will use the key ID that is indicated in the received packets, kind of just like how the keychain is. If these keys are different, meaning the egress and the ingress keys, OSPF goes into a migration phase and then sends out as many packets as there are keys, using each key for the packet. So basically it's saying, okay, I'm trying to send a message with key 1, I'm receiving packets with key 2, I'm gonna pretty much flood out all these packets, or I'm gonna flood out my hellos with different keys to see which ones you're gonna respond to. So this is the migration phase. The migration ends when all neighbors have migrated to the same key as the one used to sign sent packets to the router. All right, sort of a big process, but when I configure this, I'll show you how it works. Alright, so let's jump on the CLI. I'm using EVNG in this topology. I just have a a virtual iOS and a VMX router. And I'm just going to be using these two. I was messing with these nodes earlier, but what I need to do is just with these two. So let's configure Juniper. And if we look at that interface, we're looking at G0005. So let's go ahead and configure that. We'll go configure, we'll say set interfaces GE005 unit 0 family inet address. We'll say 12.12.12. We'll say he's 2/24, and we'll say set interfaces loopback 0 unit 1 family inet address 2.2.2.2/32, and set protocols OSPF area 0000 interfaces all. So right now I'm just giving simple IPs and turning on the OSPF process just to make sure we have connectivity first, then I'll turn on authentication. Let's commit and quit. Now let's go over to the iOS router, configure the same thing. Config T interface loopback 1 IP address 101.1.1 255.255.255.255. No shut interface G0/0 IP address 12.12.12.1 255.255.255.0. No shut router OSPF 1 network 0000 255 area 0 and show IP interface brief, and we got OSPF going. So I should be able to see the loopback of router 2 or the Juniper router. Once they show IP OSPF neighbor, once they do, we're in the full state, so we should see it. There we go. Ping 2.2.2.2 from source 101.1.1. Good, now we have loopback connectivity between these two devices. If I do show IP OSPF interface brief, you'll see that I have two interfaces in OSPF. If we go over to Juniper, show OSPF interfaces brief, we have these two interfaces. This is just a management interface not being used for anything. If I do a show route, you can see that we have OSPF routes here. Okay, good. Now, what we do to set keys, if we go back to our slide real quick, is we say set protocols OSPF area, go into the interface, and then turn on authentication. All right. And again, Juniper is going to be using the highest valid key if there are multiple keys on an interface. So what I'm going to do is I'm going to create key 2 first, then I'll create key 1, and in the configurations, key 1 will be at the bottom, but OSPF is going to be using key 2. Okay? So we configure mode, set protocols OSPF area 0 interface /5.0 authentication. The question mark should be MD5. What's the key number? I said I was going to create key 2, and then the key is going to be I'll just say Cisco. I'll say Cisco. I could do a start time right now, or I could do another command with that. I don't know the exact start time right now, so I'll leave that off, and then I'll do a run show system uptime so I can get the current time, and then we'll say the start time is going to be in the format of 2019-12-31 dot, what is it, 1851? 18:51. Start. Let me commit this one first. I want to make sure that the key is there. Exit, show configuration, interfaces. Nope, it's protocols. Protocols OSPF. So here we have key 2. There's the key in the MD5 hash, and the start time is now. If I go show OSPF interface GE005.0 detail, it'll say that OSPF is turned on and it's actually using key 2 and it started at this time. Now let's go and create key 1. Hit the up arrow and I will say Cisco 1 for key 1, and then I will start it at that same time. Commit, exit, show OSPF, I'll hit the up arrow. So it's still using key 2 here, and if I do a show configuration protocols OSPF, we will see that key 1 is below key 2 in the configuration. They have the same exact start time. They're both valid, but key 2 is actually being used. Okay? So now let's go over to Cisco and set up the MD5 key there. If I do a show route, I should lose my OSPF adjacency, which I do. Show OSPF neighbor. I have no OSPF neighbors because we're using authentication now. And we got a console message from Cisco saying that we lost our neighbor. Show IP OSPF neighbor and no neighbors. Show IP OSPF interface brief. And we're still running OSPF, but now we're not passing authentication, so let's pass authentication. The way that you do it in Cisco, you go into the interface and you say IP, I think it's OSPF, OSPF authentication message digest to turn it on, right? And then you say what is the key and then the ID. Okay. Now, when I do this command, remember, whatever the newest key is, it's going to try to use. So right now, OSPF is using key 2. So let me create that first. Message digest key 2, MD5, and the password is just Cisco. Our neighbor should come up now. Let me exit out. There we go. And show IP route. And we got an OSPF route from source of loopback 1. Good. Now we have connectivity. So let me do a show run interface G0/0. So that is the newest key that we are using. If I do a show IP OSPF interface G0/0 detail, no detail, you can see here at the bottom of this command, cryptographic authentication enabled, youngest key ID is 2, so that's the youngest one, so that's what we're using. Let's create key 1 now. Config T, interface G0/0, hit the up arrow, and we will say key 1 with Cisco 1. And let me copy that, and let me hit the up arrow real quick. All right, Now we see a different output. The youngest key ID is 1 now because I just created it. Rollover is in progress. One neighbor is using an old key ID 2, algorithm MD5. So it's trying to roll over to the youngest key, but it can't because the other side doesn't want to speak key ID 2 at the moment. Or key ID 1. It's using key ID 2 because it's set in Juniper, right? Show protocols. Nope. What am I looking at here? Show configuration protocols, OSPF. It's using the highest key. If I were to remove that, it would fail over to 1, and then Cisco would be happy. So let's actually go in there and delete it. Configure, delete, protocols, OSPF, area 0000, interface, G05, authentication, MD5, 2. Commit. And let's see what happened here. And it rolled over because Juniper is now using key 1. Exit, show OSPF interface, GE5.0 detail. And now it's using key 1. All right. And it is the youngest key, so that is happy. Everyone's happy. Now let's create a keychain and go through how that works in OSPF. And remember, I'm using EVE-NG here. I just have a virtual iOS and a virtual MX router. I'm using like 14.1 version for VMX. So, all right. Now let's configure a keychain here. Config T, we are going to say keychain. We'll call it OSPF. Let's create key number 1. And then we will say key string. So key 1 was actually Cisco 1. We are going to use the cryptographic algorithm of MD5 just so it matches Juniper. And then we will say do show clock. And we will say we will send this key. What's the send lifetime of this key? When do we want to start sending it? We want to start it now. So we will say this. Today is the 31st of December 2019. And then when do we want to stop? We could say infinite. We can say duration. Let's just say this key never expires. We'll just say infinite, just for this lab. Okay. We can create key 2 now. Key 2. Hit the up arrow. MD5. Key string is just going to be Cisco. And then the send time will be now and infinite. The accept time, when do we want to accept it? I didn't do that on the last key. Let's do accept lifetime. We'll do 1 year from now. So what I can do here is probably do that 2020 incomplete command. Oh, when do we want to start accepting it? Oh, okay. We'll accept it now, and then the duration will be infinite. I have to do that for key 1. And show run section keychain. So I created a key string called OSPF. I have key 1, which has a key string of Cisco 1, we are going to start accepting packets that have key 1 in it along with this MD5 hash starting now, and then we are also going to start sending packets now with key 1. Key 2 has the same exact configuration, except it's a different key ID number with a different key string. Remember what I said, OSPF is always going to be using the highest key ID. All right. So how we apply this is we go into the interface, and if I do a quick do show IP OSPF interface G0/0, right now it's using key ID 1. Let's enable the key string for it. So we say IP OSPF, it's probably authentication keychain, and then the name of the keychain, OSPF. When you do this, this overwrites all the interface key commands. It'll ignore all the commands actually. So once I enable that, type exit show run interface G0/0. You'll see that these keys are here, but it's not using it. It's actually using the keychain. Show IP OSPF interface G0/0, and it should say it's using a keychain now, and it's using key 2. It's sending key 2. We should actually lose our neighbor relationship because I believe OSPF on Juniper is using key ID 1, which is true. If I do a show route, it still has it, but we should be losing our neighbor relationship right now. We've got to wait, I guess, 40 seconds. Let's do a continuous ping. 101.101 from source 2.2.2.2. Oh, no route. We just lost it. Okay. Because right now it's using key 2. Juniper is using key 1. So how do we fix this? We could delete a key. We could add another key in Juniper. I'll probably just do that just to satisfy everything. Configure set protocols OSPF area 0000 interface GE0/5 authentication MD5. This is the key number. Key 2 with the key of Cisco. Start time is now. Actually, if I just hit start, that'll work. Nope, I guess it actually needs it. 2019-12-31 dot whatever the time is. I hate the time format. 1851. Commit. Exit. Yep, neighbor came back up. And if we do show OSPF interface 5.0 detail, it's using key 2 now, and show IP route. Yes, we have it. One thing I want to point out when we are actually transitioning keys, okay? If you want to do a proper key changeover for every 4 months, 6 months, however your time interval is for security purposes, for Juniper, all you're going to do is just add the new key and then add a start time every 6 months. And remember, in Juniper, OSPF is going to be always using the highest key ID that is valid. Okay, so if I want to change over a key 6 months from now, then I say MD5 3 with the key, whatever the password is, and then the start time 6 months later. And you just keep doing this. You could do the show OSPF interface detail command to see what keys actively being used, and then you can delete the old keys. On Cisco, if you're using a keychain, what I suggest that you do here is, since OSPF is always going to be using the highest key ID, have an infinite key be key number 1 or key 0, just so if all other keys, if you forget to change the date on the keys or you didn't set a new key that is valid, it'll always use the lowest keychain, or the lowest key, which has the infinite lifetime. And then just set the send and accept interval every 6 months with a new key. Okay, so that concludes this video. Hope this was informative for you. Thank you.